going to be recording in here, just so you know. Okay, your voice may be on the recording. Yes. All right, here we go. Chapter 4. Doesn't it feel so good to be back? Say yes. Yes. Okay. No. Burn. Was it hard to get up today? Yeah, I had to wake both the children up. All right, here we go. Chapter 4, trigonometric functions. I like to just shorten it, trig functions. All right, we're going to split up 4.1 into 2 lessons. These lessons are really big, these lessons in this chapter. So there's no way we could do all of 4.1 today. All right, so what we're going to do today is we're going to focus on angles. Okay, angles. And the angles are going to be inside of triangles, and they're also going to be inside of circles. So we're going to talk about angles and their measure. And you already know how to measure an angle. Using what unit of measure do you measure an angle? Degrees. Okay, we're going to learn a new measure today called radians. Anyone ever heard of radians before? A couple of you? Yeah? Physics, right? Do you use radians in physics? You use degrees mostly in physics, huh? Okay, so here we go. We have 3 parts today, A, B, and C. Oopsie. So letter A. So let's talk about degrees and radians. Degrees you feel comfortable with because it's what you've always learned. You've got a, what's that called, a protractor? Is that what it is? Yeah, I haven't taught geometry in 18 years. I hope I never have to teach that again. I might quit my job. Did anyone like geometry? Some of you guys did, huh? Yeah? You might like trig. Trig is it's kind of geometrical. All right, so basically what you have is, let's say you have a circle. Not so great. How's your circle? Good? Jerry, your circle's good? Oh, I'm sorry. I interrupted you. Okay. All right, so let's say you have a circle. And in the middle of your circle is your center. And what we do is we usually draw just a straight line, like the x-axis. And then you're going to take that line and you're going to rotate it open, okay? And you're going to get about, I don't know, to there. Doesn't matter. Okay? And angles going in a counterclockwise direction are positive. They open that way. Have you ever wondered, like, when you have quadrants and they're labeled 1, 2, 3, and 4? Didn't that seem weird that you're going in a counterclockwise direction? It's because of angles and the way they open. They open in a positive direction going that way. Okay, so we call this angle in here, we call it that guy. What is that? Does anyone know what that is? Theta. Theta, good. Okay, this right here looks like that. It's a Greek letter. It's called theta. It's on your calculator too. You see it? XT theta N, theta. Theta is our central angle. It's called a central angle because it's in the center of a circle. Theta is our central angle, okay? Now what happens is you can make this into a triangle. See that right there? Triangle. And what you have here is you have, we can call this, see, I don't like it because they label them different letters later on. But this is this is the radius, right? This side right here, that blue side, that's the radius of our circle. It's also, what is it of that triangle? It's called something. Hypotenuse, yes. R is the radius of the circle, but it's also the hypotenuse. That reminds me of a joke. First joke of the year, here it is. What do you call the upstairs bathroom when someone's using it? It's a hypotenuse. It's so good. Okay, and then over here, this green one, that's just a side. Boring. That's just the side. Oh, you know what? I'm not going to call it that. I don't like that. That's just the side of a triangle. We're not going to call it anything. And then over here, this red part, see that right there? That's the curvy part. Okay, we're going to call that S because they call it S later on. And S is the arc length. Arc length. basically, we have degrees. We can measure that angle in degrees, okay? So degree is just going to be an angular measure. Angular measure. Now, how many degrees make up an entire circle? 360. 360 degrees make up an entire circle. Do you know why 360? Like, why not 100? Why didn't they say an entire circle was 100 degrees? They picked 360 for a reason. They actually chose 360. It wasn't like, here's the circle and it's 360 degrees. No, they actually chose, that's a random number. It is. But 360 is very close to how many days there are in a year. But they don't want to choose 365. They chose 360 because 360 is divisible by 30. It's divisible by 60. It's divisible by 120. It's like a really good number that's divisible by a lot of numbers. So they chose it. Weird, huh? Back in the day. And then they use degree for a lot of things. They'll use it for navigation, for surveying, all kinds of stuff. Okay, now if we want a more precise measure of unit than just like 36 degrees, what if it's 36 degrees and a little bit, but not quite 37 degrees? Okay, that's when we get into something called DMS. Anyone know what DMS is? Ooh, no, new stuff, cool. D stands for degrees, minutes, seconds. Like a clock, okay? Each degree is subdivided into 60 minutes, and then each minute is subdivided into 60 seconds. Okay? And we're going to go ahead and learn how to convert from degrees, minutes, seconds to just degrees. And you're going to do this on your calculator. So go ahead. Did you bring your calculator today? You haven't seen your calculator in a while. I couldn't find mine at first, but there it was waiting for me, sitting in a desk all of Christmas break. So that brings us to our first example of the year, calendar year. Number 1. We're going to use our calculator to convert. I don't know why this isn't working well. I wonder if it's this. Use our calculator to convert. So let's start with something that is in decimal form. So letter A. Oh, that's better. We're going to convert 37.425 degrees into degrees, minutes, and seconds. Okay? All right, so go to your calculator. Grab your calculator. And do 37.425. Okay? And now here's a new button for you. New year, new button. Go ahead and hit second apps. Do you see where it says angle? Angle? Second apps. We're not going to use a whole bunch of this stuff, but we are going to use numbers 1, 2, and 4. Okay? So right now we're going to use number 4. Do you remember that fraction button that has a little triangle, change things to fraction? That's what this is. This is change this decimal to degrees, minutes, seconds. So you plug in the number 37.425, and then you're telling it to arrow it to make it into degrees, minutes, and seconds. And that's the way it's written. Okay, so this would be 37 degrees, 25 minutes, and 30 seconds. And of course, you can do this by hand if you needed to, but we don't want to. All right, we can also go the other way too. So the other way is to be given 42 degrees, 24 minutes, and 36 seconds, and we're going to change this into degrees. Okay. Now, this bothers me about your calculator a little bit, that they didn't put them all together, but they didn't. So what you want to do first is you want to go 42, go to that angle, and choose the degree symbol. 42 degrees. 24 minutes, so 24, go back to angle again. Minutes is number 2. See the one little dash thing? Now, we have to do seconds. And seconds, if you noticed, is not in the same spot, which is weird. Why not put that as number 3, right? And don't use minutes twice. That doesn't work. But seconds is found, do you see it anywhere? It's on your calculator. You see it? It's alpha plus. Look at your plus. Do you see it there? The two things? Yeah. Alpha plus. And there it is. What a weird spot for it, huh? Yeah. I know. When I was at the Texas Instruments calculator conference, I should have mentioned that to them, that they should change that. But all right, hit enter, and there you go. So that gives you 42.41 degrees. Okay? Sometimes we're given it in minutes and seconds. Sometimes we're not. It just depends on the problem. I like them in just decimal form a lot better than minutes and seconds. And think about this. 24 minutes and 36 seconds is not quite half an hour, right? Like 24 minutes. So 0.41 is not quite 0.5, not quite half of a degree or half of a decimal there. All right. Now, that's degrees, and you should feel pretty comfortable with degrees. You know how many degrees it is when you open stuff. Now we're going to go ahead and talk about radians. This is still letter A. So what in the world is a radian? Okay, I'll tell you what a radian is. Let's say, I wrote it in words earlier, but people got really confused, so let me write it in a picture instead. Go ahead and draw a circle again. And give yourself a radius. Okay? We're going to call this radius, we'll just call it A. So the length from the center out to the side of a circle is A. And what I'm going to do is I'm going to jump on this circle and I'm going to follow it until I get that same length of A. And when I do that, what happens is I get what's called 1 radian. Okay? 1 radian is when the radius and the arc length are exactly equal to each other. So let's say if I were to go around a circle, okay? And let's say, let's just do, and I went 1 radian, so about to there, and then I ended up going another radian. So now that's 2 radians. If I were to draw an angle to there, that would be 2 radians. And then I go to here, which would be 3 radians. So I have 1, 2, 3 radians. All the way to 180 is exactly, it's a very special number that's just after 3. Pi. This is pi radians. 180 degrees, write this down, is exactly pi radians. And that has to do with the circumference of a circle. What's the circumference of a circle? 2 pi r, right? Well, if I only go half, that's just pi r. And if this is r and this is r, if that's equal to each other, then you get your pi radians there. We're going to use that a bunch, okay? Now, there's some very special angles for radians. Here, let's do some of them. We're going to do 2 circles. None of my stylists are working today. Look at that. Huh, it's like they all went on vacation. Do I have one on this side? Nope. Okay, back to my other one. All right, let's do 2 circles. And let's take 1 circle and let's break it up into quarters, okay? So 1 quarter, there's another quarter, that's 3 quarters, and that's 4 quarters if you want to call it that. All right, so you should be pretty confident on what the degrees are for each of these, okay? So if you open up to here, you get 45 degrees. Okay, so how many radians is 45 degrees? Well, let's look. An entire half circle is 1 pi radians. So how much is this of that pi? Pi over 4. Perfect. Pi over 4 radians. You have to be pretty good at fractions here. Okay, people think an entire pi is the entire circle, like you're going to eat like a cherry pie or whatever, Banbury pie. This right here, an entire pi, is just the top half of a circle. So when you go to a quarter of it, See, there's broken up into 4 slices of that pi. You're at pi over 4 radians. So what would then 90 degrees be? Pi over 2. It's half of the pi, isn't it? Pi over 2 radians. Okay? And then if you go over to this angle in blue, this one to here, that angle is 135 degrees. That would be how much of the pi? How much? 3/4 of the pi. Yes, so we call that 3 pi over 4. There you go. And you can keep going all the way around. And the funny thing about angles is they don't stop at 360. They can keep going. Okay? So if I wanted to draw something like 3 pi, I could go like this. 1 pi, 2 pi, 3 pi. 3 pi is 360 plus 180. What is that? 540? 540 degrees. Okay, so 3 pi radians is 540 degrees. All right, now let's go over here and let's break this up into thirds now. Thirds get a little tricky, but they're very special angles, okay? So if I went to 1/3 of 90 degrees and 2/3 of 90 degrees. 1/3 of 90 degrees is 30 degrees. Can you read that? 30 degrees. 30 degrees is equal to, now let's see how many pies I broke this up into. Yes, I heard it. Someone said it. Wow, that's really ugly. I need to redo that. Here we go. So I have 1 pi, 2 pi, 3 pi, 4, 5. So how many pies did we break this up into? Or slices? 6. 6 of them. Okay? So this right here, this 30-degree angle, is pi over 6 radians. It's 1/6 of the entire pi. Then what's 60 degrees? Here's 60 degrees. 60 degrees is pi over 3. It's 2/6, right? And 2/6 reduces to pi over 3. Isn't that funny? That 30 degrees is pi over 6 and 60 degrees is pi over 3. And think about it, 30 degrees is small. It's just 1/6 of the pi. 60 degrees is bigger. It's 1/3 of the pi. Okay, if I go over to this right here, this angle, let me draw it in green. This angle right here in radians is how far? The green angle is 5 pi over 6. Exactly. It's 5/6 of the pi. I have 1, 2, 3 pi over 6 is 1/2 pi. Here, that would be 5/6 pi. 5 pi over 6 is what we call it. And what it's doing is, see, if you can think of it this way, it's missing 1/6 of the pi. So an entire pi is pi. Missing 1/6 would be 5 pi over 6. You're going to get used to these. I know it looks a little weird right now, but you'll get used to them. Now, in the meantime, if we don't know them, we can actually do some, oh, this is part B, converting. Okay, we're going to convert. We can go back and forth. You know how, like, you probably learned this. Oh, you know what? My son does this. He's in 5th grade. Like, how many inches are in a foot? You know, stuff like that. Conversion factor. So we need a conversion factor. So if we're going from radians to degrees, then we're going to multiply our angle measure by 180 over pi radians. Okay? Radians to degrees. You're going to multiply by 180 over pi radians. And if you're going to go from degrees to radians, then you're going to multiply by pi radians over 180 degrees. You just flip it. They're equal to each other. 180 degrees is pi radians. It's exactly 3.14 radians. Okay, so let's do some. Here we go. Number 2. Convert. We'll do radians to degrees first. Okay, that angle that we just did, 5 pi over 6. how many degrees was that angle? 5 pi over 6. Well, we know it's less than 180. It's between 90 and 180, right? So let's go ahead and we can use our conversion factor here. We're going to multiply by 180 degrees over pi radians. By the way, when they write 5 pi over 6, sometimes they don't write the word radians because we just know that it's radians. They do that all the time. Degrees, you want to put a little degree symbol. But radians, they just will write, 5 pi over 6. We know it's radians. Okay, so I multiplied it by 180 over pi radians so that my radians will reduce. It's like that stoichiometry stuff you did in chemistry, right? Moles and all that, remember? But a little bit easier. And then you can also reduce the pi's. So you get 5/6 of 180. It's 180, but we only want 5/6 of that, which is what? 150 degrees. Perfect. 150 degrees. Okay? Or you could have thought, all right, it's 180 and it's just 30 degrees less than that. Is that what you did? Yeah, good. Okay, let's find out how many degrees is 1 radian. Not 1 pi radians, just 1 radian. Remember I drew 1 radian where it was at? It was in quadrant 1. So let's find out how many degrees is 1 radian. It doesn't matter what the size of your circle is. Your circle can be massive. And as soon as your radius of your circle equals your arc length, it's going to be the same degrees every time, no matter if you have a teeny tiny circle or a huge circle. So 1 radian, 180 degrees over pi radians. It's not going to be a pretty number. Okay? So the radians will reduce, leaving you with 180 divided by pi. And it's about 57.29 degrees. So it's just a little bit under 60 degrees. Too bad it can't be 60, but it's not because of pi. Pi's in there. Makes everything kind of ugly. All right, how about 7 pi over 4? 7 pi over 4. Let's go ahead and find out how many degrees that is. You're going to get pretty good at this where you won't even have to use the converting. Some of you might already be able to do this in your head. So 180 over pi radians. The pi's are going to reduce, leaving us with 7/4 of 180, which is 315 degrees. Now let's talk about that really quickly. 7 pi over 4. Well, what's 8 pi over 4? Yes, 8 pi over 4 is 2 pi, right? 360 degrees. So 8 pi over 4 is all the way around. Well, guess what 7 pi over 4 is? 7 pi over 4 is almost all the way around, but I'm going to stop 1 pi over 4 short of that. And that's why you get, this is 45 degrees to the rest, and so you just take 45 off of 360. Okay? All right, let's do number 3 now. Let's go the other way. Let's convert degrees to radians. So let's do 130 degrees. 130 degrees. Let's find out how many radians that is. And leave it in terms of pi, okay? Leave it as a fraction. So we're going to go 130 times pi over 180. So the degrees are on the bottom now, so that the degrees, when I multiply, the degrees will reduce, leaving me with just pi radians. We don't write it a lot of times. And you get, what is that? Does that not reduce very nicely? So you go 130, you can use your calculator if you need to, divide by 180. Don't write 0.7222 pi. That's gross. Okay? Change that back to a fraction. So this would be 13 pi over 18 radians. I know that looks kind of gross, but that would be the answer. And you don't even want to write 13 over 18 times pi. You write it as 13 pi over 18. All right, how about something like this? 720 degrees. Woo, it's hot. 720. Let's find out how many radians that is. I like radians better. You might not yet. You might later. But 720 degrees would be really hard for me to think. When I change this back into its radians, pi over 180 degrees, what do you get? 4. You get 4 pi. 4 pi, I can visualize what 4 pi is. 4 pi looks like this. Here's 1 pi, 2 pi, 3 pi, 4 pi. That would be the angle. Okay? And that's how you write that angle or draw it. Isn't that weird? Super weird. All right, last part, part C. Ooh, 10 minutes. Part C. All right, we're going to talk about arc length now. And we are actually given a formula to memorize here. We're given that S is equal to R times theta. S equals R theta. What do all these letters and things mean? S is the arc length. R is the radius. And theta is the central angle in radians. That's going to be super important. It's the central angle in radians. This formula does not work if theta is in degrees. So anytime you're doing this formula, you're going to need to change anything that's in degrees to radians before you use this formula. Okay? All right, I've got 2 more examples, and then we're done. Number 4. All right, they tell us that the arc length of a certain circle is 2.5 inches, 2.5 inches, and that the degree of the central angle is 45 degrees. Okay? So if I drew a picture of this, here's my 45-degree angle. This arc length right here is 2.5 inches. And guess what they want us to find? They want us to find the radius. Okay? Find the length of the radius. All right, we can do this now using arc length equals theta times the radius. Okay, first of all, let's change theta back into radians. Okay, 45 degrees. Some of you might need the converting factor, which is fine. Some of you guys might look at that and say, oh, that's how many radians? Pi over 4. Very good. It's 1/4 of that pi, which is the top half of a circle. So that's just pi over 4. You're going to get really good at these, I guarantee you. Okay. All right, so now let's plug everything in. S is 2.5 equals R times pi over 4. And then let's solve for pi over 4. Let's multiply both sides by 4 over pi. Okay, and you go to your calculator, and anytime they're asking you for a length, you'll want to put pi into it, like you'll multiply by pi. If you're asking you for an angle measure, you want to keep pi as pi itself. So you go 2.5 times 4 divided by pi gives you that the radius of that circle is about 3.18 inches. Here we go. Okay, nice little warm-up problem for these. And they get a little bit more complicated, like number 5, last one of the day. All right, so 2 nights ago, I threw a pizza in the oven, gave it to my kids, asked them how many radians they wanted. They didn't know what I was talking about. You know, like a slice of pie, pizza, right? Okay, anyways, we're going to have a 60-degree slice of pizza. That's a pretty good size, right? 60-degree slice of pizza. And the pizza has a 7-inch radius. We want to find the perimeter of our slice of pizza. Perimeter of just our slice. Okay? Our 60-degree slice of pizza. All right, so let's go ahead. Let's draw it. What kind of pizza do you like? Pepperoni? No? All bunch of stuff on it? That Canadian pizza's nasty, though, with the pineapples. I can't do it. My kids, guess what they like? Cheese. Just cheese, nothing, not even pepperoni. Too spicy. Yeah. Yeah. Yeah, they're a bunch of wimps. My kid the other day, my 5-year-old, he was eating a candy cane, and he said it was too spicy. That's so cute. What a cute word to use. All right, here's about 60 degrees of a pizza. Here it is. Did you ever think about how much you're eating of a pizza in radians? No? You might know. All right, there you go. Okay, so now we've got to find the perimeter. The perimeter is to do what? To add up all the sides, right? So in order to find the perimeter, I need this length, which is 7. I need that length, which is 7. Cool. But I also need this length here, which is a curvy length. So let's go ahead and use our formula. Okay? S is what I'm looking for, equals theta times r, or r theta. So 7 times, now what's 60 degrees? How much in radians is 60 degrees? Yes, pi over 3. If you're not quite there with us, you can use your conversions. 60 over 180 is 1/3. So this would be times pi over 3. So we're going to go 7 times pi over 3. And that gives us that the arc length is about 7.3 inches. Were you thinking it was going to be pretty close? Because remember, 1 radian is 57 degrees. So at 60, I'm just past 7 on my arc length. That's 7.3. Ooh, that makes sense. Okay, so now to find the perimeter, I'm going to take all the sides and add them up. So 7 plus 7 plus 7.3 gives me about 21.3 inches. Cool. All right.